In section 5.6, we look at factoring trinomials, and this is one of the more challenging sections for a lot of students. So a trinomial is a polynomial of the form ax squared plus bx plus c. And we're going to start with the case where a is equal to 1. And actually, I'd like to look at how you multiply these polynomials together. So when multiplying two binomials like x plus 3 and x plus 4, we start by multiplying x times x, which gives us x squared. And then x times 4 gives us positive 4x. 3 times x, positive 3x. And finally, 3 times 4 is positive 12. And then we can add these two middle terms together, 4x plus 3x, to get 7x. So this process is called multiplication. Factoring is when we undo that process. So factoring is what we do to go backwards. And so some of you probably already know how to factor, and if that is the case, then you are in good shape. What I want to do is talk about the method for factoring for those of you who struggle or for those who may not have seen this before. So when going from the polynomial x squared plus 7x plus 12 back into the product of two binomials, what you have to do primarily is look at these two numbers. So positive 12 and positive 7. And when we're factoring, we are looking for two numbers that multiply to give us positive 12, and those same two numbers need to add to get positive 7. And so what I like to do here is just make a little x. This is sort of our magic x. And I'm going to put those two numbers, positive 12 on top and positive 7 in the bottom. And we are searching for two numbers that multiply to give us 12 and add to give us 7. And I'm sure many of you already know what these numbers are, but let me list the factors of 12. So 12 can be 1 times 12, 2 times 6, or 3 times 4. Out of these possibilities, 3 and 4 are the numbers that we're looking for. Those are the numbers that multiply to give us positive 12 and add to give us 7. Therefore, when we factor, we're going to have the product of two binomials, one of which will be x plus 3 and the other one x plus 4. And that's just a direct transcription from these numbers here. We just bring these numbers over. So that's a relatively simple example. Let's look at some more. So in our first example here, we're looking to factor the polynomial x squared plus 8x plus 15. And so I'm going to make my magic x, put 15 in the top, 8 in the bottom, and I'm thinking about factors of 15. So numbers that multiply to give us 15, but add to give us 8. And this probably doesn't take too long to figure out that the two numbers need to be 5 and 3. And so then when we factor this, we should get x plus 5 times x plus 3. And of course, you can always check your answer by multiplying it out. So if we multiply this out, we get x times x is x squared. We get x times 3 is positive 3x. 5 times x is positive 5x. And 5 times 3 is positive 15. And mostly we're checking to make sure that when we add those two middle numbers together, 3x plus 5x, we get 8x in the middle. Let's try the next one. So for our next problem, we have x squared minus x minus 12. let's keep in mind that this is negative 1x in the middle. And we are looking for two numbers that multiply to give us negative 12 and add to give us negative 1. So if you think about factors of negative 12, you could have negative 1 times 12, or you could have negative 12 times 1. You could also have negative 2 times 6, or negative 6 times 2. And you could have negative 4 times 3 and negative 3 times 4. So you have more possibilities because the product is negative. But out of all of these options, the one whose sum of the factors equals the middle number, which is negative 1, would be the factors negative 4 and positive 3. And so that means when we factor this, we're going to get x plus negative 4, which is x minus 4, and x plus 3, which is x plus 3. And again, you can check. So for our next example, we have x squared minus 12x plus 36. And it's the same procedure, except now our last number is positive, but our middle number is negative. And so when we make our magic x, and we put positive 36 on top and negative 12 in the bottom, we are looking for two numbers that multiply to give us a positive, but add to give us a negative. This can only happen if both numbers are negative. And so what factors of 36 would give us a sum of negative 12? Well, let's list our factors of 36. We could have negative 1 times negative 36, negative 2 times negative 18, negative 3 times negative 12, negative 4 times negative 9, or finally negative 6 times negative 6. And out of all of these options here, the only two factors that add up to negative 12 would be negative 6 and negative 6. And so when we factor this polynomial, we should end up getting x minus 6 times x minus 6. And that can be simplified to x minus 6 quantity to the second power. Number 4 is very similar. And so in number 4, notice that our last number is positive 25, and our middle number is 10. And the only factors of 25 that would give us 10 when we add them together would be 5 and 5. So for this one, when we factor it, we're going to have x plus 5 times x plus 5, which can be simplified to x plus 5 to the second power. And these last two examples here, number 3 and number 4, these polynomials are called perfect square trinomials. And the reason they're called perfect square trinomials is because when you factor them, you get a perfect square. And if you had known that before you started, it would have made the factoring a little bit easier. So one thing I always remind my students of is anytime you see a perfect square on the end of the polynomial, you should think about using the perfect square root factors first as an attempt to see if that works. All right, so now we're going to continue on with factoring trinomials, but now we're going to take the case where a is not equal to 1, so the number in front of our leading term is not 1. One thing you need to remember is you should always factor out the greatest common factor whenever it's possible to do so. So notice in this example here, every single coefficient in this polynomial is divisible by 5. So I can factor a 5 out of this polynomial, and what we'll have left over is x squared minus 2x minus 8. And now we can do a magic x problem for the polynomial that's left over on the inside. So negative 8 goes on top, negative 2 in the bottom, and the two numbers that you can multiply to get negative 8 and add to get negative 2 would be negative 4 and positive 2. So to finish this up, this is going to factor as x minus 4 times x plus 2, and you need to remember to keep the 5 on the outside of the parentheses since that is part of the answer. Number 6 is pretty much the same thing, except that in number 6, notice that we don't have a number in front of x squared other than negative 1. So remember that this is a negative 1 here. And factoring is always easier when your leading coefficient is positive. So the first thing I want to do in this problem is just factor out the negative 1. And when we factor out the negative 1, that just makes every term become the opposite of what it was. So now we have to factor what's left over, x squared plus 3x minus 10. We can make a magic x for this. Negative 10 goes on top, positive 3 in the bottom. And the numbers that multiply to give us negative 10 and add to give us positive 3 would be 5 and negative 2. And so to finish up the factoring here, we know that this polynomial is going to factor as x plus 5 times x minus 2, and then don't forget to include the negative sign on the outside. That needs to be part of your answer. The next two examples are a little bit different. In our next two problems, notice that we do not have a greatest common factor to factor out. 3 does not go into 13 and 10 evenly. So in this case, we have to employ a special modification of our magic x problem. Now you need to pay attention very carefully, as this can be a little bit confusing if you don't know the exact steps. So the first thing we're going to do is we're going to take the leading coefficient and multiply it to the constant term. So 3 times negative 10 is negative 30. And then the middle number, 13, goes in the bottom. So again, our top number is no longer just the constant. We have to multiply it by the leading coefficient. Now what I'm doing is I'm looking for two numbers that multiply to give us negative 30 and add to give us 13. What are those numbers? So without too much trouble, I hope you come up with 15 and negative 2. 15 times negative 2 is negative 30, and 15 plus negative 2 is positive 13. Now, when we go to factor our trinomial, we can't use these two numbers because these two numbers do not multiply to give us negative 10. So we have to do a modification here. And this is the modification. When factoring, we're going to put the x here, and then it's going to be plus 15, but we're going to divide it by the leading coefficient, which was 3. And for the other one, it's x minus 2, but again, we're going to divide the 2 by the leading coefficient, which was 3. So we take these two numbers, but we divide each one by that leading coefficient. Now, when you simplify this, what you get is x plus 5 and x minus 2/3. If you have a whole number here, then this factor is done. But if you have a fraction left over, like we do here, the trick is we now take this 3 and we move it in front of the x here. So we're going to take this number and move it to here. And when we do that, we get x plus 5 times 3x minus 2. And this is our answer. Now, if you don't believe that, you can always check your answer. So you can multiply this out. X times 3x is 3x squared. So that's this term times this term. X times negative 2 is negative 2x. 5 times 3x is positive 15x. And 5 times negative 2 is negative 10. And if we add these two terms together, notice that we get 3x squared plus 13x minus 10, which is the problem that we started with up here. So just to make sure you're clear, this is the answer. This is checking the work. Let's try another one using that same method. So for our next problem, notice once again we have a leading coefficient that is not 1. What I'm going to do is take that leading coefficient and multiply it to the constant term at the end of the polynomial. And 2 times negative 18 is negative 36. And then I'll take the middle number, which is negative 9, and put that in the bottom of our magic x, just like before. Now we're looking for two numbers that multiply to give us negative 36 and add to give us negative 9. So again, you might need to run through and remind yourself of the factors of 36. So 36 times 1, 18 times 2, 12 times 3, 9 times 4, and 6 times 6. And if I want this to be negative 36, one of these numbers needs to be negative. And then, of course, I could have put the negative on the other number as well. But I can see that to get negative 9, I need to use the factors negative 12 and positive 3. So now we're ready to go ahead and factor. What I'm going to do is create two sets of parentheses, and we're going to have a t here and a t here. The variable is t in this problem. And then the negative 12, I'm going to bring that over, negative 12, but I need to divide that by this leading coefficient. And then the positive 3, same thing. I bring this over here, positive 3, but I need to divide that one by the leading coefficient as well. And when we do this, we get t minus 6, and then t plus 3/2 does not simplify. And if you have a fraction left over, the last step is take that denominator and sneak it in front of the t here. And then you can check your answer to make sure that this is correct. And it is. I'm not going to go through it, but it is correct. Now, this is not the only way to factor. This is sort of a tricky way to factor. Some of you may use trial and error. In other words, you might just think about what you need to multiply to get these polynomials. You may not actually go through and use the magic x at all. And if that's the case, that is perfectly fine. Okay, let's look at just a few more problems here. Now, notice in our next problem, we have 9x squared and positive 25. If you multiply 9 times 25, that's a pretty large number. And large numbers are difficult to factor. So what I want to notice here is that we have a perfect square here. In other words, 5 times 5. And we have a perfect square here, 3 times 3. if both your leading coefficient and your constant term are perfect squares, this is probably a perfect square trinomial, meaning that I can go ahead and just give it a guess as to what the factoring is going to be. So to get 9x squared, I'm going to try 3x times 3x. And to get 25, I'll try 5 times 5. And both signs need to be negative since we have a negative in the middle. And now I'm just going to check this answer. If I multiply 3x times 3x, we get 9x squared. 3x times negative 5 is negative 15x. And then 3x times negative 5 again is negative 15x again. And finally, negative 5 times negative 5 is positive 25. And what you notice here is that you get negative 30x in the middle, which is what we were looking for. So the bottom line is, this is the correct answer. But then we notice that each of the factors is the same, so that means we can simplify our answer by writing 3x minus 5 to the second power. So I didn't do a magic x for this problem because, again, if I do 9 times 25, we get 225. And finding the factors of 225 would be not impossible, but definitely time-consuming. Now, in our next example, we have a slight variation. Notice that the constant term is first and our highest power of x is last. If you ever run into this situation, I highly recommend that you rewrite the problem by switching everything around. Now, the x to the fourth power is actually not that big of a deal. In fact, we know that if we were to factor this, if we have x squared here and x squared here, we know that x squared times x squared would be x to the fourth. So really it just comes down to figuring out what my numbers are. So I'm trying to make 40 for the product and 13 for the sum. And we know that 8 times 5 is 40 and 8 plus 5 is 13. So when factoring, we're going to have x squared plus 8 and x squared plus 5. In number 11, again, we have very large numbers here. And if we were to multiply 14 times 28, that would give us a pretty large number. But you really need to pay attention because in this problem here, all of these numbers are divisible by 14. So you can factor out a 14. So it'll be 14 times x squared plus 3x plus 2. And then we just need to factor what's left over on the inside here. So we do a magic x. We're looking for two numbers whose product is 2 and whose sum is 3. And that has to be 2 and 1, right? 2 times 1 is 2 and 2 plus 1 is 3. So when factoring here, we have 14 times x plus 2 times x plus 1. So the moral of the story here is, don't forget to factor out the greatest common factor anytime you can. And so sticking with that same theme for our last problem, notice that this problem looks rather complicated. However, every single term has an a, and every single coefficient is divisible by 5. So I can actually factor out a 5a. And if we pull a 5a out, we get x squared minus 6x minus 7. And so now the problem looks very simple. So factoring out the greatest common factor is always a technique that you want to use because it makes the rest of the problem easier. So now I make a magic x, negative 7 on top, negative 6 in the bottom. Two numbers that multiply to give us negative 7 but add to give us negative 6 would be negative 7 times positive 1. And so when you finish factoring this, you're going to have x minus 7, x plus 1, and of course make sure you have the 5a in the front. And so this concludes factoring trinomials. But we're going to jump on to the next section and look at some special factoring. There's basically two types of special factoring that we look at in this section. The first type is called the difference of two squares. And the difference of two squares, a squared minus b squared, always factors as a minus b times a plus b. And if you don't understand that, you can simply multiply this out to verify that this is actually true. So notice that if we multiply this out, we get a times a is a squared, a times b is positive ab, negative b times a is negative ab, and negative b times b is negative b squared. And you can see what happens is the positive ab and the negative ab cancel out, and you end up getting a squared minus b squared. So anytime you're factoring the difference of two perfect squares, it's going to factor using the square root of each of those perfect squares, and then you'll have a negative sign and a positive sign. So in our first example down here, we have x squared minus 25. Now you don't have to take this next step, but this is the same as x squared minus 5 squared. And this factors as x minus 5 times x plus 5. And I'll let you verify by checking. How about number 2? 9x squared minus 16. If you want to express that as the difference of two perfect squares, we can say that 9x squared is 3x quantity squared, and 16 is 4 squared. And once you identify that, you can easily factor this as 3x minus 4 times 3x plus 4. And again, you can check at any time. Now for problem number 3, we have 20x cubed minus 125x. So to do this one, first of all, I want you to notice that as it currently sits, this is not the difference of two squares. 20 is not a perfect square. Neither is 125. Neither is x cubed. But one thing that we can't overlook is the fact that there is a greatest common factor of 5x here. You can factor a 5 out of 20, and you can factor a 5 out of 125. And you can also take out an x. And so if we factor out the 5x there, we end up with 4x squared minus 25. And so by factoring out the greatest common factor, what we have left over now is the difference of two squares. And that can be factored quite simply because we know that 4x squared is 2x times 2x, and then negative 5 times positive 5 to get negative 25. So again, don't forget to factor out the greatest common factor anytime you can. Now in our final example for the difference of two squares, you actually don't have a square at all here, you have a fourth power. But a fourth power actually is a perfect square because x to the fourth power can be thought of as x squared quantity squared, because if you multiply 2 times 2, you get 4. And then 16, of course, is 4 squared. And so when you factor this as the difference of two squares, we will have x squared here and x squared here. And then 16 is 4 times 4, and we have one negative and one positive. So it's pretty straightforward to factor. But the key point here is that we're not done factoring because x squared minus 4 is also a difference of two squares. And it can be broken down further into the product of x minus 2 times x plus 2. And then x squared plus 4 does not factor further. That's the sum of two squares. And we cannot factor the sum of two squares. You can try, but it's not factorable. So the final factoring technique I want to talk about is the sum and difference of two cubes. And this is the hardest one, I think, because it's the longest formula. But I'm going to try to give you a way to think about it that's a little bit simpler. So if you have the sum of two perfect cubes, a cubed plus b cubed, it factors as the product of a plus b times a squared minus a times b plus b squared. And if you have the difference of two perfect cubes, it factors in a very similar way, except that a couple of your signs are different from above. So these are formulas, and those formulas are only good if you can memorize them. So I'm going to try to show you a way to sort of paraphrase the formula in your head so that you can remember this a little bit more easily. So we'll start with factoring x cubed minus 27. And I purposely took the formula off the screen because I don't actually want you to see it as we do this problem. The first thing you need to do when factoring the difference of two cubes is you need to express it as the difference of two cubes. So we have x cubed minus 27. 27 is 3 to the third power. So it's important that you take this step, that you put a cube here. Now you know from the formula that we had a binomial multiplied by a trinomial. Now the binomial is really, for the binomial, all we're going to do is take these two terms and bring them down without the cubes. So we're going to have x minus 3. Now for the trinomial, what we do to get the first term is we take this x here and we square it. And to get the last term, we take this 3 here and we square it. And the last term is always positive. So the only thing left is, how do we get this middle term? To get the middle term, we multiply these two terms together. So x times 3 is 3x. And then the last thing is, what sign do we put here? A plus sign or a minus sign? Well, if this sign is positive, this sign here is always the opposite of that first sign. So if this sign is negative, this sign will be positive. If this is positive, this will be negative. So we have a negative here, that means this needs to be a positive. And that's all there is to it. So we'll just clean this up. This is x minus 3 multiplied by x squared plus 3x. And then, of course, 3 squared is 9. Now, I know that that probably doesn't make sense after one attempt. So let's try another one. Let's do this one next. So 64x cubed minus 1. First thing I need to do is express that as the difference of two cubes. 64 is 4 to the third power. So 64x cubed is 4x quantity to the third power. And then 1 is the same as 1 to the third. Now this is a difference of two cubes again. We know it's going to be the product of a binomial and a trinomial. And the binomial is just bring these two terms down without the cubes. So that's 4x minus 1. And then in the trinomial, to get our first term here, we're going to take the 4x and we're going to square it. And to get our last term here, we take the 1 here and we square it. And that's always positive. And to get the middle number, we take these two and we multiply them together. So 4x times 1 is 4x. And whatever sign you have here, you have to have the opposite sign here. That's it. That's all there is to it. So now we just clean it up. This is 4x minus 1 times 4x quantity squared is 16x squared plus 4x, and of course 1 squared is 1. All right, and so for our last example, factoring, in this case, the sum of two cubes, again, the first thing you need to do is you need to express these as perfect cubes. So 8x to the third power is 2x quantity cubed. And 125y to the third power is 5y quantity cubed. Once you do that, then you know you have a binomial and a trinomial. And for the binomial, you just drop these into place. And so this becomes 2x plus 5y. And by the way, that sign drops down with it. And then in the trinomial, we are going to take the 2x here and square it, the 5y here, square it, and then in the middle, we will multiply these two together. So 2x times 5y is 10xy. And if this is a positive, this has to be a negative. And one other thing I forgot to mention, on the 5y quantity squared, this is always a positive. And so now we just got to clean this up. So our answer is 2x plus 5y multiplied by 2x quantity squared is 4x squared minus 10xy and then plus 25y squared. Okay, I have a lot to do in this couple of sections here, so you should really get to work right away.